main thing is on your own.
We're not gonna get anything.
Listen,
I spent 4 hours today. I'm still not done chapter 1.
I'm saying, so it's going to take the main thing, obviously, like always, is on your side.
No, like, I can do this easily, you know, if I'm not working or if I'm, you know, just sitting around and you know, I'm saying if I do 1 chapter a day, I'm still going to be completely, you know, even now I already know chapter 2. Like.
Okay, so we'll do chapter 2 now. You guys we'll have to after this class tonight, we'll have to make a call so we can commit for how much.
I don't care, but if you think we're good, we're good.
Okay, so let's get into chapter 2. Okay.
So, who you believe? You believe to what is it name? Slavery or bread?
Huh? Okay, you guys ready? We're on for a while already. Okay. So every single piece of Java is in a class, right? Every single thing. Okay, in chapter 2, guys, when we read chapter 2, in the beginning they have an awesome example, which is the difference between object-oriented programming and standard procedural programming. Okay, read that example. It is an awesome example, and it'll clarify things very much of how Java works. Because you guys are right now coming from SQL. SQL is an awesome language, and in many respects, way more easy to use and more powerful to use than Java when it comes to handling data. But for what Java is good at, you have to understand what Java is all about. So read that first example, and then we're going to go through the basics of it right now. Okay? Okay, here we go. So everything in Java is in a class. Okay? Every single thing is in a class. A class is like a blueprint of what you're going to make. So let's open up a paint thing here. Let's go through that. So like, for example, if we look at over here, let's look at this example. Okay? Got this example over here? Okay, let's look at it over here. Okay, so we have over here a song class, right? Every single song has a title. Every single song has the artist, right? The title will say be, you know, Butterflies or whatever it's called. Give me a famous. The artist would be the Beatles. Famous song would be, I don't know, you know, Can't Buy Me Love. Okay, right? So let's make a quick instance of that. Okay.
What is it?
Instance means this is like a blueprint. This is almost like a cookie cutter. Now let's make one. So we make a song. So you have a thing. Let's call it, you know, we'll call it song 1. Oops. What's going on
It's
here?
called, you can plan pencil tool.
The what?
Pencil tool.
Thank you. Make it red so it's pretty easy to see. Okay. So let's make 1. So we'll call it song. What is going on here?
So this is what the name of the song and the other what you want.
It's saying subject and adjective.
Man, this thing's not working anymore. That sucks. There it is. 1 second.
No time, no time.
Hold it. Hold it for a second.
Should we walk my arms?
It should work.
And it's really big. The thumb?
It's weird.
No, it's not that. I mean, this is working fine. Look over here. Working fine. Something's wrong with this pencil thing.
I think you need to sharpen it.
Alright, that sucks. I just bought this piece of crap.
See what it means when you buy from Amazon? Thank God for insurance policy. You can return it.
The what?
It's from Amazon?
No, I got it right over here in the stores.
Really?
Yeah.
You?
Huh?
No Amazon anymore?
It's so weird. No, what's wrong with this thing?
It works when you hold it down, which is weird.
1 second. Let's close that for a second.
Oh, I think you are.
do you think? Okay, it's working now. I don't know. Okay, so let's do it again. Here we go. Okay.
Why not using the software?
Okay, so here we go. Okay, we're over here. So here's a song. Let's make one song, okay? So let's call the first song, you know...
What? A song? I'm gonna give you a
Don't try
song.
this again, man.
You gotta press the pencil.
Snoop Dogg.
And
Okay. Okay, so let's make one song. What do you want to call the song?
Tupac.
Okay, Tupac.
I know, but you know, I don't know the title.
Okay, Tupac, and it's called the song, you know, Get in the... Okay. Okay, so the title and the artist, that's one song, right? It's called the song 1. Then it's called song 2.
In
And
the
this-
same class?
Remember, class is nothing real. It's just a blueprint. Okay, so this song would be called, you know, this would be from, let's call it Shuku, whatever his name is, right? The song would be called Go Go. Okay, this would be song 2. Okay, what's the main thing over here is that these are instances. Instances, or you can call them objects. Okay, of what? Of this. So this record over here and this record over here are instances of the song class, or object of the song class. Okay? That's how Java works. It's object-oriented programming. You make a class, which is like a template, and then when you in the JVM, when you start running the program, you can make these things, make these objects. Right? Objects don't exist until runtime. They don't exist yet until you actually run it. These classes exist even when the program's not running. They're just imagine on the wall you have different cookie cutters. One cookie cutter makes this shape.
It's like a function, no?
Yeah, but the cool about class is that you start thinking almost the way the world works. So for example, you are Regev, so you be part of the person class. Right? You're one person. Your eyes are brown, so that's your eyes, that's your instance variable over here. Okay, your instance variable of eyes would be brown. Mendel's also a object of person, and his eyes are whatever it is. Beard is red, right? Okay, so just remember this. This is like a cookie cutter. Okay? Okay? That's all it is. We have instant variables. That defines the state. Methods define the behavior. This is what it knows. This is what it does. Okay, so for example, if I say the song, you know, the song's title is Tupac, right? The song's artist is Tupac. That's an instance variable, an object variable, right? An instance and object are really the same thing. Okay. So this concept to get down really clear. So when you create Java programs, you are really what you're doing is making classes. When you run them, then you create you create objects out of it. Or you can make some test objects, but usually these things, by the end of the day, you have to store them where?
What?
Store them in the JVM.
After the JVM. But what happens if you they only want to bring it back?
Then
The Bizarro would just be for the classes itself, for the data itself. Say I'm in a JVM, and I make a record, another song. Where does it get stored?
In the class.
The class is just a cookie cutter for this. So the answer is it doesn't. Once memory is gone, you turn off the computer, it's gone. That's why you learn SQL, because we learn later on how Java interacts with SQL. You can start a database and pull back out of the database.
So
this is difference. This is the difference between Java.
This is the top layer.
This is just a layer that runs.
The top SQL.
Right. Okay. Let's do a quick example.
So to get a song from SQL?
Yeah. If you have songs, and artists inside of your database, that will pull it out.
Okay. So here's one very important thing. When you design a class, you think about the data an object will need to know about itself. That is the instance variables. You also design the methods that operate on that data, and that is the methods. Okay?
This is chapter 2.
This is chapter 2. Okay, so the most important thing to remember is that, going back to here, is that these and these all operate on when you create it on the object, right? For example, if I go over here and I press play, right? So I'm over here and I'm on, and I go, just make sure this is recording. Yeah. Okay, so say I go to here and I press play, right? I'm on song 1. I go song 1 and press play. It's gonna play this song, right?
Right.
If I go over here and press play, it'll play this song. In other words, the methods in a class use the state of that one. So this object has a different state, therefore the methods behave differently. This object has a different values and instant variables, and therefore its methods behave differently.
So you need to write a code when you type play. It's gonna play the artist and
Right.
the title and that's that you wrote.
Right. So if I go over here and I do, let's look at an example first of all. Okay. So we have. Remember, a class is not an object. It's just used to construct them. A class is a blueprint of an object. Okay. Okay. So let's look at this example on the top.
So the song, the class, go as well.
One more time.
You shut off the computer, class is gone.
The class is never anything. Class is just the class you save in a file. That's another. The objects will be gone. The class, remember, is just for example. Let's look at some. Let's look at a
Well,
quick example.
it's based. I mean, I get what it is. It's
Measure
The class only holds the object, you said?
Class-
all the objects.
Class is just measured. On the wall, you have a cookie cutter that's shaped as a star.
Well, it's it's a computer. It's a robot. So the robot, whatever you have in front of him, is going to use those things. But with the robot itself.
But it's not even a robot because it all does is create something for you. It's a cookie cutter. It's a tool. So you have on the wall say you have dough in front of you, and on the wall you have a cookie cutter shaped as a star and one shaped as a square. You take up the star, snap a piece of dough. Now you have a dough that looks like a star. Put it back in the wall. The class is just that tool. Now you have on your table you have a star-shaped cookie dough that exists in memory. You shut down the computer, you shut the program, boom, it's gone. If you want to store it later on, we're going to learn how to store it in a database and then bring it back to life.
Does that work for
the actual code in the class.
Now, the class is a file. It's just look. Let's look here, guys. A good example.
Is that why it's called cookies?
Can you?
Is that why it's called cookies?
No, seriously.
What?
Cookies on your computer.
Oh, for that.
Is that why it's called cookies?
I don't think so. I have no idea. I don't know too much about how cookies work.
Maybe you should.
Okay, here we go. Ready? You guys ready?
Mm-hmm.
So let's look at a simple example. Here's class, dog. Int size has integer size. It has a breed, which is a string, and has a name as a breed. Okay, so what are these called?
Those variable.
Yes, but there's a better word. I mean, there's two words.
What
Instance.
do you call it? A variable?
Variable.
Instance. Okay, these are instance variables.
Yes.
Okay, what is this?
That is the return, yeah.
Okay.
Always hard.
Okay, so this is a method. Okay, so all this method is going to do is print out rough. Okay, so this is.
But it's what is the main? Not for
No, we don't need a meaning here because we're gonna call it from this one.
you're gonna call from this one.
Yeah.
So that
The time?
No, this is what he's teaching us now.
Okay, so watch.
Oh, no.
So this class just defines what a dog is. A dog has 3 instant variables. One is its size, its breed, and its name. It also has one method that it barks. Okay?
Okay.
You know, let's also go over here.
What?
And,
Not
what?
who?
Let's also do. Okay, let's do like this for now. Okay, this one. You know, let's actually.
How do you call? How are you going to call that? Import?
Name. Can't see my thing. Plus.
It's called your mama.
Okay, so it's gonna do out. It's gonna do that. Okay. It's gonna say. It's gonna say what the dog's name is. Says rough when you call that. Test dog drive is a class, and this is just our test driver. It's gonna test our dog to test it out. So if we're gonna do. Right, this is what runs the program that always looks the same. We're gonna make a new dog, set its size to 40, and let it bark.
But
Why is that weird? Why
What
is
weird?
that color oriented?
Can you hear?
Why is that color oriented?
Wow. It's operator. Really.
It's not Java. It should be color oriented.
Wait, what's wrong with the color?
Oh no, it's not color.
He's basically saying that d dot size equals 40 and d dot arc. Those objects aren't colorblind.
What's not color?
Orange is not yellow.
Which one?
It isn't supposed to be.
Orange.
And you probably set your different color
Yeah,
computers.
you have a different color.
Yeah. Yeah, you do one, whatever works for you. Okay, set the name.
How do you know?
Set the name.
How do you know that you called to the other class, to the Java? How do you can you explain me?
1 second. Okay, so here we go. So let's look at this one time, guys. Because it's late. 5:30 already. Class. I'll make a simple dog. Here's a dog. It has different things and it can bark. And when it barks, it says its name that it barks. Now we're going to test it out. So over here, we're going to create a new dog called D. D dot. This dot is how you access instant variables and the methods. So D size. In other words, this dog's size equals 40. Dog's name equals Fluffy. Dog's now go ahead and bark.
And how are we supposed to know that this is supposed to connect to that, not the other dog? Or
So since we're now under the same folder, Java is smart enough to know that when you press dog, it's going to look inside your folder and look for the dog class.
Oh, the
Take
dog
that
is
class.
letting you know where to call it to the dog class.
Yes, this dog over here, when it calls new dog, it says, oh cool, let's look in this folder for a new dog tool. Looks in the folder, there is this dog tool, off the wall, boom, make a new dog called D.
So these.
Well, you wrote new dog. What does new dog mean? Does that mean that you actually make a new dog, or it's just a new dog? Is that a command?
A new dog object.
I'm
Is
taking,
new dog a command? New dog
Yeah.
is a command saying I make a new dog.
Yeah.
Not just any freaking. I can write new puppy and I'll show up as puppy.
well, there is no class called puppy.
And that's my question. If I write new dog, that means it has to go under the class. That second letter, when I say new dot, that whatever is in that letter, that is going to the class.
This over here, yeah, if I do new and then do dog, this must be a class.
That's on that.
Yeah.
So why do you ever write dog D?
Can you?
Why are you
So
writing
dog is the type. Remember how we did string, like over here, integer, string?
Yes.
The variable D now holds a dog. Instead of over here, size, integer, right, is size, right? Size is an integer.
Yes.
This is also a variable, right? But this variable is not holding integer or size or a string, it's holding an actual object. This is the first time we're
So D is basically
A variable.
That whole entire class.
it's an object now, yeah, based on that class.
Cool.
Let's call it a better name if you can understand it. Let's call
No,
this
it's pretty, I get the
let's
point.
call it dog 1. Okay? Okay? In fact, let's create another dog while we're here also. Okay, let's call this
How do you
Dog 2.
bark on those?
Okay, and this one, let's make this like size 5, and let's call this dude dog. Okay? So now we're basically in this test drive. Over here, this is called test drive. Ignore this. This is anytime you have your main method, it's going to look like that. So let's look over here. We're making a variable called dog1, and it's going to hold a dog. Okay? Now that besides doing that, let's assign it. We're going to make a new dog. Boom, a new dog. Make it size, make its name, go ahead and bark.
Size name of.
Can I do all this with like SQL?
Can hear you?
Can I do all this with SQL minus the mark?
Can you do this all with SQL? Well, let's look at that later. You're asking very good questions of what should be part of SQL. As of now, we're going to learn things in Java, and then as it mixes into SQL, you'll get to decide when SQL is best, when SQL is not best.
This is just like data, is it?
This is data. You're right. So, yeah, good. It's a good question to keep in the back of your mind.
Okay, so ignore SQL data.
Yeah, ignore SQL until we hit that. But no, keep it in mind. So you can just let's go ahead and compile those. Okay.
So basically, instead to write a new code, you just call to the class and add the parameter.
Say it again. Okay, so now we're gonna run it. Ready? Java. Okay, we're gonna run it now. See what happened?
Lapis say run. The dog say run.
Okay.
Same language.
Okay, but you see now, what you do right now looks very simple, but you're actually learning some pretty heavy-duty concepts. You're learning really object-oriented programming. Okay, you learned the idea that we had a cookie cutter. Over here, we took that cookie cutter off the wall and made two of them. Made two dogs. Changed those dogs variables for each one of them and caused it to bark. We saw how bark, even though we hear, right, it looks the same, we put the name over here so that it says something different.
What does the name mean?
Name points to the variable, which over here we set to Fluffy or Dude Dog. Okay? Okay, and we'll see soon how powerful it gets. You see already one very cool thing about Java is that in objects, all that you need to know about a dog is right here, and all the things a dog does is right over here.
Yeah, but it doesn't really say anything about the size of the breed of the dog.
One more time?
It doesn't really say anything about the size of the breed of the dog, so why do you need it?
I mean, right now, yeah, this is just a
You're basically just testing.
Yeah, yeah.
But technically, I'm saying, obviously, you don't even need any of this, because you can put it right here. You don't need to.
One more time?
You can put that whole entire thing that you just put over there, right here.
You mean under it, make a whole new thing that calls this dog class?
You can put in system outprint, let's say, breed
size equals this.
Right.
Yeah, I can put it over here. Yeah, 100%. Yeah.
The point of this is testing.
Yeah, we're testing this out. We're taking this class off the wall, and this is how you really should do your programs. Your classes should be cleaned, no testing in there. Then you create a testing one to start testing out to make sure it looks fine.
Okay.
You want to do it, make some of the classes, make sure it looks good. Okay. Over here we didn't really put that much in there. Okay, let's now go continue. Okay. Okay. So next thing we have is that the idea of inheritance.
I saw in. Okay.
Next thing we have is the idea of inheritance. Inheritance we'll talk about it now, but we'll leave it for the next chapter, so we can get
So what is it, chapter 2 right now?
We're doing chapter 2 now. The entire chapter 2. Okay. So what's inheritance? Okay. Say we have over here. That's an example that's in the book. If when you get to the book, it'll be familiar. Okay. So say we have a shape. No, not that. Okay, so say the task is as follows. Okay, so we have to make a shape and make it rotate and play a sound.
Okay, I know it's in chapter 2, but
Yeah.
what are you trying to tell us?
Okay, so look at this. Look over here. Check this out. Okay, looking. We're gonna do this. Just do this outside. Later on, when the book starts talking about more depth, we're gonna go back into it. Okay, so don't worry. And we're gonna talk about this now, but you're not just so you can appreciate what Java is about. But we're gonna save the actual how to do it more in depth for a next chapter. Okay, so here's an example of a shape class. Okay, the shape, you can make it any shape you want, right? And
like circle,
right.
This
Yeah, and it has two methods: to rotate and play a sound. So it spins and it'll sing a special sound. Right? Okay, so that's cool. So say we have now, we end up making a couple different shapes, right?
Brad's shape. No. Brad's version of the program.
Brad was names?
Yeah.
Okay, so here's the cool thing. Say you when you're off the bat, you recognize that there's going to be, you want to make this powerful thing. So make a square subclass. Why do you want to make a square subclass? Subclass is a class in itself, but it is based on this one. Okay, so if you notice over here, square and circle and triangle don't have any methods. They pull exactly what's within shape. So if I press square, if I go over here, for example,
Okay.
watch, I'll make this a little more clear for you guys. Say I go over here. Okay, so say I make over here, I make a new, let's call it a square. We'll call it square 1. equals new square. Okay, so now we have this square 1 variable that's holding the square. Okay, I can now go over here and do square 1 dot rotate.
And that'll rotate the square.
I rotate the square.
Does it know how to put it? It knows already that it's a square once you put it in a square, or?
We're going to learn later on how you tell the square that it's based off a shape.
So right now it just has like a non-existent thing that rotates.
Don't worry, behind the scenes we'll make things, you know, that once you create a square automatically it'll state that it's a square.
So
Right.
The point is that everything that's in here,
every class you make a subclass, and inside the subclass you make square, circle, and you make the shape.
so basically
Inside
you can say that a class is based on another subclass, therefore you don't have to reuse code.
Yeah, you make it in. Okay.
Okay? So say for example there's dogs, right? But there's
So
different types of dogs.
Square 1, use square, square. What did they do it? Circle, circle 1, and new circle.
Yeah. Okay? And is everyone still with me?
Yeah.
Okay? But say you have an example that its rotate does something different than what it does over here rotate. Right? This is where object-oriented programming is very powerful. Okay? So this code works. Say we didn't create this yet. Don't look at this thing for yet. Okay? Say we didn't create this yet. All we have is shape. We make these subclasses, and they rotate and play sound fine. But say we have to make a new shape that its rules for rotating are very different. It rotates in a different way. When you press rotate, it starts rotating like this and backwards, whatever it is, special rotation. So we cannot use the code that exists over here. That rotate just says spin in one circle, 360 degrees, whatever it is, 360 degrees. You can override and say over here that we want to use rotate, but we're going to give it a special code that does rotate only for this class.
Oh, okay.
Okay? So what's cool about this is that we don't have to change any code.
Just in a subclass.
In the subclass we'll change it. Now, we're going to leave it, right now it's not going to make 100% sense, but just leave this in your mind, the idea that we can have layers and layers of classes. Okay? What's good about this? The cool thing about this is you don't need to touch things that have been tested already. You just add a new feature. Right?
So you don't need to touch in the class.
Say, for example, this shape is working fine, and these work fine. But now you got a new requirement that an automobile has to rotate differently. It's special way of rotating. Well, over here you just say, okay, I'm going to override it and make my own rotating. And it works fine.
Okay.
Okay? With SQL, you can't do that.
You can.
You can't.
Okay.
SQL, you have to change the thing and say, oh, if it's this, if it's that, then do this and that. Over here, you can make your own separate file, and it works just fine without changing anything else in the code. Okay? Don't worry, right now, all this stuff is going to be more theoretical, but once you start learning more of the examples, it will get much more concrete. Okay. Let's go to,
Different book, this one, no?
this is my notes.
This is your notes?
Yeah.
No way. This is your note.
Yeah.
Oh wow, it's good. I didn't.
Yeah, you have to make awesome notes. I'm telling you, it's gonna be your lifesaver. Literally, it'll be your job or no job. That's what's gonna make your thing.
How can you get this note?
Spend a lot of time on your notes.
You have to teach me how to do it.
What, notes? I basically just take from the book and then put it into my own little format.
Yeah.
Okay.
Really cool.
Okay. Let's.
Can you print me those notes?
I don't want to do it because it's not. Your notes only make sense to yourself. It's not gonna make any sense for you. But I could, but it's not. It's gonna defeat the purpose. Okay, here we go. Ready? Let's look at a big example of chapter 2. Ready? Hold on your seats, guys. Here we go.
So what you show us with the dog is also subclass.
Yes.
No, there's just one class. There's no subclass.
Well, no, the other one, the dog test, is that sub?
Which one?
With the dog test.
It's not a subclass. This is just this class is calling this class.
So how do you create subclass?
We'll talk about that in some later chapters. A subclass is a different idea. Subclass is, for example, imagine this. Say we have creatures as class 1. Under creatures, we can have person class and dog class that are both
In
creatures.
the same code, in the same class.
Different classes.
But in the same source?
Different files. Each class is, remember, one file per class, and one class per file. We have 3 different files that they reference each other. We'll go to that soon. Right now, let's focus on more on this chapter. Here we go. Okay, we have over here 3 different files that refer to each other.
Okay.
Okay, it's a guess game.
Should I already?
Okay, so let's look over here.
So you teach us something with the sub, or this is something else?
I'm going to run this game. By the way, press, if you want to clear the screen, press CLS. Clear the screen.
Yeah, but this is a subclass, or this is...
Don't know. For now, I just tell you theoretical subclasses. We're not going to touch subclasses in this
So now
class.
what do you teach us?
We're going to show you a game based on objects. This is one class.
Object.
We're doing object-oriented programming. That's what we're teaching. Okay? Don't worry about the subclasses yet. That will be for later on. But just I want to touch upon it so you at least get the idea. But right now we're just going to do the idea of classes that are not subclasses. We're just doing basic classes. Okay? Let's look over here. The game is as follows. Watch. I'll run it for you. Okay? Here we go. Here's the game. The game starts off that the computer says I'm thinking of a number between 0 and 1. It then takes a random number, so the random number over here is 6, and then we have 3 players. And the players guess a random number, which also by using random. They guess 5, they guess 4, they guess 2 and 4, right? All wrong, because it says player 1 guess 5, player guess 2, guess 4. Players will have to try again. There's no 1-1. Okay, let's loop again. Number to guess is 6, right? Stays the same. 5, 6, 1. So 1 and then 1 over here. It says player 1 gets 5. We have a winner. It goes through them. Player 1 got it right? No. Player 2 got it right? Yes. Okay? Game is over.
So this is chapter 2, we're going to build it in chapter 2?
Yeah.
Nice.
Okay, so it's a guessing game. Okay? It's a guessing game. There's really no guessing from you. It's the computer's guessing. So the computer's generating a random number, makes 3 players, and the players generate a random number to see if it matches.
So wait,
Let's run it again. You see this time it's different. It took a lot more time for them to win. You see? Run it again. This time it took that much time. Okay, this was a quicker one. It was 9. They get 64. No winner. 9, 53. No winner. 9, 9, 6, 8. We have a winner. Who's the first one? Okay, so let's look at the code. Okay, here we go. So let's look at the. We'll start with the simple ones. Okay, let's look at the player. Okay, that's one of the classes.
You started there?
What? Yeah. So here's a player. The player has a number that it guesses. This is the guess number. It's an integer. It starts off at 0. Okay. It has a method that's called guess, where it changes this number to be a new number that it guesses on. This should look very familiar. It's a number from 1 to 10, right? It's math.random, times it by 10 because it remembers only from less than 1, and makes a number. Okay? And it prints out, this is what it prints out. I'm guessing. Can you hear you?
Y equals 0.
Why does it equal 0 over here?
Number equals integer math at random times 10, which is fine, which means it's dealing up to 10 between 0 and 9. I don't get why integer number equals 0.
Over here, you're saying. It's a good question. You probably can take this out. You probably just leave it into number.
Why? But it doesn't matter. I want to understand why you didn't equal 0. How are you allowed to do that?
Because you're using
technically,
hold
if
something.
the number equals 0.
I'm missing your
If the
question.
number equals 0, the number is 0 times 10.
Why?
Because this number equals integer math at random times 10.
But this,
But integer number is
we're just
0.
overwriting it. We're overwriting
So
it.
it's not saying that it equals 0 automatically. It's just saying it's for the guess code.
This is at first it's to hold 0, but once I run this, it overwrites whatever's in
I
it.
think you don't have to have the 0 or something.
Okay? You probably don't. You probably can
Yeah.
this as is.
Because
And anyways, if you go like this, in any case, take that out, it'll be 0 anyways. Because once you create an int number, it'll make it 0 behind the scenes. This overwrites it. So all the player does, a number. It has one instance variable and it has one method. The method guesses a number and puts it into that number variable. Okay, so I can run it once. It might be 1. I run it once. It might be 5. It might be 6. But it's 1 to 10.
Okay, I got you.
Okay.
Sounds good.
Now we have a guess. Let's go to the game launcher. It's very simple. We'll start with the simple ones. The game launcher will launch the game. We haven't looked at the game yet, but it says I want to make a new game, which we're going to look at in a second, and start the game. That's all it does. And if you notice, this is the main method. This is the one we're going to launch when we want to start the game. Like if we look back over here, we ran
Go back.
Java game launcher.
Yeah, I say go back there. Okay, so game, guess game, new guess game.
Right, so it's going to make a new guess game and start
So
it.
new get you call to that.
This one, and we're going to start it.
Okay, so
Okay.
what did the guess game?
Okay, so we have the player down. That makes it, that just, you can make any many players and it'll guess their numbers. Game launcher just launches the game. Now let's look at the guess game.
Okay. So this is chapter 2?
This is chapter 2.
No way.
Yep.
So it's not a Java beginner.
This I told you, this book is a good book.
I know,
It
but
is not.
it's not a Java beginner.
Oh, it is.
Okay, so now check this out. The guess game. This is, remember, it's one class per file. That's good about Java. It keeps things simple. You don't have to start, look, there's just one class in there. Guess game is the class. There's 3 instant variables. What are the 3 instant variables?
What? P1, P2, P. This is a variable. Okay.
These are what? What are these called?
Variable.
The instance variables. They always say instance because there's different type of variables.
So
This
how
is-
do you know what is it that is instant?
Because you see over here in public class, remember that, it's defining these as instance variables. Later on we'll learn about different type of variables, but this is very important to understand that this is an instance variable.
This is what everything is about.
Is before the voice.
It just like in dog, we had the size, and we had, the breed. So too a guess game has 3 players. In this case, these 3 players are referring to different
Basically, you
objects.
just say subject.
Can you hear you?
Well, subject.
What called subject?
It's a variable. They're the subject.
These variables are what it knows, not really the subject.
Well, what is our subject? Our subject is the sleep language, right? Or the subject is the guessing game. That's the guessing game.
Okay.
So the variable before the void is instance.
Yeah, just like we had in dog.
Yeah.
These are the instant variables. Over here, they happen to be simple data types. We have an integer and a string. So too over here,
But you can have them like a number, like P1 equal had, you know what I mean? That's a load.
but look, if I do equal 1, that's not true because this is a player data type that equals this. I can do new player.
Oh, okay.
Okay. Okay. So we have 3 players. We don't assign them yet until you start the game. Like when you hear you start the game, then it starts doing playing the game. Okay. So it starts the game. What does it do? It first assigns 3 players. Right? It fills up that variable with 3 different players. Player. So we have now 3 players. Okay. Let's start step 1 of the game. Step 1.
For the other, like you play like 1.
Remember, it creates 3 of these. So we have 3 players now. And as of now, all their numbers is 0.
Oh, okay.
Okay? Then we just say that their guesses are, as of now, just 0. We'll see why we do that soon. Okay? Again, now we set that they have got it wrong, just because we're about to go to the loop. So as of now, nothing's correct yet, and they're all 0. Okay? Now we over here, the next 2 lines.
Boolean P1 is right.
This here, right or wrong.
Okay, now for these next 2 lines, we make the number for the game, right? Just like over here. We say over here that, let's clear the screen so it doesn't look like it should be. Okay, so you see over here, it says I'm thinking a number between 0 and 9?
Yeah.
Okay, I'm thinking a number between 0 and 9, right? It first sets the first guessing number, okay? Then now we're going to enter a loop, okay? So this loop goes all the way from here to here. It's a massive loop. But basically it says just keep on going until I say get out of it. While true will always be true. Break knocks you out of the loop. Okay, so if this break wasn't there, it would run forever.
Like waiting forever, like.
Because we're not.
Yes.
It'll always run. Of course.
Yours ran. That's what I'm saying. Yours ran. If you look at your thing, it ran until it was. So not till it was true, but after that.
No, that's true.
Really? Right over there. It says we have a winner.
Right.
Next one, game is over.
Right. Look, we have a winner. Game is over. Break and jumps out of the loop.
Oh, that's true.
Okay. Okay, so let's walk through it. So we now that we're in the loop, let's start the game. So number guess is 7. That was a random number I chose. Now, you see over here, guess 1 equals P number, P1 number,
Yeah.
right? It's going to those players and getting their number.
Okay.
Okay?
The numbers on the top.
One time? Yeah. So we have the numbers over here. What does this guess do?
It takes the guess from this there.
Right. We have guess. Remember that was the thing? So it changes that person's number. So we're guessing for each person. Person 1, you guess. Person 2, you guess. Person 3, you guess. Okay? Now we just spit out what they guessed. So you see over here, player 1 guessed 2, player 3 guessed 0. Then you go over here and we check if they're right or wrong. If guess 1 equals the target number, right? Target number is what the system wants you to meet. If yes, makes it true. If not, it just leaves it as is. That was false initially. Okay, and here's the main part. If player 1 is right, or player 2 is right, or player 3 is right, remember these are ors, right? Then spit out, we have a winner. If not, then say we have to try again, and the loop continues, and does again, spits the whole thing out again.
So this is our player 1 got it right. Player 2 got it right, and player 1 is right. But that's, I mean, they were over.
Right, after when you review chapter 2, you'll go on this line by line.
I just don't get the
Which part don't you get?
bottom. So player 1 got it right. No, player 1.
So this one holds whether they got it right or wrong.
I get why it says wild true.
Wild true means run forever. That's what wild true means.
Oh, it's nothing to do whether it's true or false or true.
It means run forever. That's what it means. Because while
My point is, it has nothing to do with false and true.
yeah, because
Regards
we're not giving a condition. Remember, if you look at the old example, let's go to chapter 1.
No, that's all I want to make sure.
You had if.
Here's a while loop. Remember we here if it's more than 12, right? So we here we're not doing any condition. We're saying always run. So it's going to run while it's true. It's always true. While true basically means run forever. Except we're breaking out of the loop over here. Break is a command in itself. So it breaks out of the loop. Okay, so this is a new thing that you learn in this chapter, the idea of break. Right? If I do while false, it'll never run. While true means always run. Break, I can break out of it.
In order for a game to run, you have to do wild true.
In this type of game, this is one way of doing it. This is one way of
This is the
doing it.
way I would hack it if I was a hacker. I could just hack something.
Oh,
I want
easily,
to
yeah.
do it true. That's what I'm just saying.
Yeah.
Change it.
Yeah, so this type of game, this makes sense for. Right? Because what's over here, the condition to get out of this game is that someone won. But we don't know how many loops there's going to be, right? It can be 1 loop, it can be 100 loops. It can take 100 times before the guy wins. For example, look. This time it took 1, 2, 3, 4 times for the computer to guess it. This time it took 1 twice to get it, right?
I like it random.
So I can't really put a condition over here that I know off the bat. I don't know how long it's going to be. This is why this works good. While
That's
true,
fine. I just want to know what
Yeah.
it was.
I'm saying you can understand the reason why you use this type of thing. This is good. We don't know off the bat how many loops to do. If the game rule was you have 10 guesses and that's it, I can do, like 10 and break out of one, before that. Okay. So let's walk through it again very quickly. So you make 3 players. Right over here we have 3 players ready. We don't give
Can
them.
we start with the player.java?
Yeah. Player.java. This is a simple class that just is as integer for what number they guessed, and when you press guess, right, which is over here, p1.guess, it guesses a new number.
And that's a command, yes.
It's a method.
Sorry, a method that is a internal method, nothing to do with what we do.
Right. This is why this is what's the hardest part about Java that you have to get used to. Unlike SQL, is that whatever's in a class is meant for that class. So you notice over here, when I'm running this, the number doesn't land in here. The number lands over here.
Well, I'm asking, the word guess,
Yeah.
does that mean guess? Does it mean it's going to guess? Does that mean not random? Or does guess mean...
You're defining it over here. That's what guess means.
Public void guess. I don't see how that shows that that's guess.
Public void guess. We're making a method called guess. I can call it Ganucci if I want.
Right.
And over here, we're defining what this guess thing does. Remember, between this bracket and here, it defines what it does. This guess method does what? It makes this number equal a random number, and then tells you, spits it out.
So now I can wrote the bombshell if I wanted to.
Yeah, I can call this Ganucci, and then over here, just call Ganucci.
The math that we're on them is a command.
Math, well, you'll see later on that math is one that Java gives you offhand, but it's really the same thing.
Okay.
In other words, what you're doing is what Java did already for you in many cases. Java made thousands of files for you already, classes for you that you can use. It's the same thing you're going to do. It looks just like this. So if you want to look at math random, you can look up in their classes the math class and their random method. Random over here is just a method from the class math. Okay. Okay, so we make 3 people, make their initial state before the loop starts. Over here, get the number that we're going to use for what number they have to get, and now enter the loop to see if they get it. Okay, guess for them, see if they won. If yes, break out of it. No, loop again.
Game launcher, go to game launcher.
Game launcher just launches the game. Okay, remember it has the main method. That's what when I go over here. When I just do game launcher, so automatically hits the main, makes a new game thing, and starts it.
Go to
Watch this. I can make 2 games. Let's just see what happens. And I'll run the game twice. So I go to here, and I have to name it something else. Game 2. Just so you can get a glimpse of it. So you can see that. Now, I just
you
run
need to
twice.
change it also in the game, new game.
One more time?
You need to change it also
Why?
in the game.
This is the beauty of JavaScript. Nothing changed. I'm just calling it. I can call it a million times if I want. Okay, so let's go through that. Again. Here we go. Let's run it. Okay, so you see they ran the thing twice. Okay, so over here, let's find the first one that ends. Game is over, and then it ran again. So you see that this thing just created 2 of them and ran it twice. Okay, so that's all the game launcher does. It just creates a game instance, right? An instance of the guess game and launches it.
But eventually we'll learn how to make it user friendly, where a user can put in whatever number.
Yeah, that's the tool of programming. The easiest parts are the GUI parts. The hardest part is later on. It's called Swing. Java Swing is where you get into making interfaces or push buttons and.
By chapter 5, though, you got to go to the point already. Not chapter 5, actually, 6 or 7.
Yeah, and the book goes into it. But in the game, the book's going to create a very cool app. That's all GUI and web-based and very cool stuff. Okay, so that's really it for chapter 2. That's all of chapter 2.
All right.
So would I just go through chapter 2 and go through line by line, and make sure you understand all the parts all the parts of it. Cool. Any questions?
Yeah.
Nothing. All good.
I need to make chapter 2.